Hi everyone, welcome back to SAT Math Question of the Day. Here's our question of the day. Please look at it, try it, pause the video, come back and we'll try it. Which quadratic equation has exactly one distinct real solution? Wow, so there's the standard way of doing this is to calculate what you call the discriminant, and we'll go over this. But if the discriminant equals 0, then it has exactly one distinct real solution. That seems to be the most direct way to do it, but you have to know that fact. So what is the discriminant? If this is an ax squared plus bx plus c is equal to 0, a is the coefficient of the x squared term, b is the coefficient of the x term, and c is the constant, then the discriminant equals b squared minus 4ac. And to have this condition, one distinct real solution, the discriminant needs to be 0. So we have to test these four equations and see. That's one way to do it. We could factor each one. We could also do it graphically. We could graph each equation and see which one only crosses the x-axis once. So that's another way to do it. If you go with the calculator.
There's still a third way.
Okay.
The constant term in a quadratic equation is the product of the roots.
Right, yeah.
Therefore, if the thing's going to have one distinct real root, that root has to be 4.
Oh, right. In other words, if the roots
because it's a product of the roots,
and R2.
The only numbers whose product, the only real number whose product with itself is 16 is 4. So therefore the putative real root is 4. And therefore the equation the equation must be equivalent to x minus 4 times x minus 4 equals 0.
Right.
And therefore that if you multiply that out, that is x squared. The linear term is minus 4x times 2, which is minus 8x. You could also see it, since the two roots they're equal roots, so they're both 4. The middle term, when the I must say it's when the property that the product of the roots is the last term is only true when the coefficient of x squared is 1, which it is in all these cases. In that case, the middle term, the coefficient of the middle term is minus the sum of the roots.
Right.
And the only one who's minus the sum of the two 4s is minus 4 plus 4, which is minus 8.
And then,
so I guess a quicker way of getting is to use the use the fact that there's that they gave you the the equations in multiplied out form, in monic form. And therefore you could just read off the product of the roots, and then the equal roots. Their product has to be, each root has to be the square root of the last term. So they're real, so the last term must be negative. The two roots are 4, and then the minus sum of the roots is minus 8. And you pick off the one that is minus 8.
And then I realized another way to do it is when you have exactly one real root, the equation needs to be of the form x minus r, which is the only real root, squared. That's the only way to get one answer. Then you take square root of both sides, x equals r. So the equation must be in this form. Oh, but r could also be negative, right? R could be less than 0. So, so in other words, then, and then, oh yes, and then what is this? This is x squared minus 2x 2 minus 2rx plus r squared. So that immediately knocks out the negative signs because you can't have a negative sign here. And then
that's what the root and the square the root is real.
Right. So then the right, of course. Right. So then the only two choices are these. So these are the only two. If you want to switch to the discriminant, then you can check the discriminant on that.
Yeah.
Yeah. And then Seth noted that r must be 4. It has to be, right? And oh yeah, once you note this has to be part of the answer. R has to be 4. So then you just put a 4 in here. But r could have also been negative.
No. Well, yeah, sure. R could have been negative 4.
Oh, but they didn't give that as the answer. In other words, x plus 4 could have is also that, but they didn't give this. This would have been x squared plus 8x plus 16, but that's not one of the answers. Yeah. Thankfully, because then it would have been a problem in the SAT. Right, yeah. Wow, so there are really a lot of ways to do this. Quadratics generally have multiple ways of doing the problem, which is, I guess, good. Different aspects, different lenses that you could look at the problem through. Yep. And then if you take the discriminant of D, you see that it's 64 minus 4 times 16, which is indeed 0. So, yeah. This is a good thing to always keep in mind, that the last term of a quadratic equation is the product of the two roots. That is very handy to have. And almost as handy is to know that the middle term is the negative of the sum of the roots.
But that's only true when the first term, when the coefficient of x squared is 1.
Thanks, Seth. That's right. Exactly. This has to be a 1. Yeah.
But there's no. It's always applicable, because when the coefficient of x squared is not 1 and it's not 0, which it must be not 0, otherwise you won't have a quadratic.
Right.
In that case, you could divide the 3 terms by the coefficient, get an equivalent equation where the coefficient of x squared is 1.
Right, which means that you are simply dividing, or like I did in the green, the middle the last coefficient is r1 times r2 divided by the a. If a is not 1. Well, you're always dividing by a, but if a is 1, we just don't think about it. Yeah. Okay. Wow, so we offered a lot of different ways to do this. Graphing it, we always ask the 4 questions. Is a calculator helpful here? Right, if you're really fast with the calculator, yes, but it's probably not the fastest way to do it. Plus, notice they gave you, they were cruel. If you're testing discriminant, they were cruel. They gave you had to go through all 4 of them and get to the very last answer. It seems like they take turns on these types of questions where you can check the answers. Sometimes they're nice and they put it in the first answer. Sometimes they're not nice and they put it at the end. So that in this case, you had to test all of them. Although you could, in some ways, the negative sign here, you can almost throw those out, because the discriminant is 64, 8 squared, minus a 4 times a negative number. There's no way this is going to be 0. If this is negative sign here, when you're subtracting a negative sign, it's a plus a positive number because you're squaring it, you're never going to get 0. So pretty quickly you could throw these out, even testing with the discriminant. So these are all things to look at. So, okay. All right, the 4 questions. So we already talked about calculator. Is this different from a school test? Uh, no, well, most school tests are not multiple choice, but but yeah, you could see this on a school test. You start with the answers. Yeah, well, yeah, starting with the answers and testing the discriminants is one way to do it, not the best way, but it is certainly a way. And the main idea, well, there are a lot of main ideas. There's the discriminant, knowing about the discriminant. There's asking to see if you know the if you can do it the way Seth did it, whether you can quickly notice that the two roots are four. I mean, the roots are the same. The double root is four. And realizing that quickly, that's something they wanted you to know and test. Maybe they wanted to see whether you knew that if it has exactly one real root, the equation can be written like this, and then you could use the implications of this to help you. So it's not, because this problem can be done different ways. It's not really all that clear what the intention of the test maker was, other than understanding how to deal with quadratic equations and understanding how to deal with and understanding the facts about their roots. So that's a pretty unfortunate. That's a pretty broad topic.
Yeah.
Yeah.
And of course includes that subsequently the basic arithmetic. Yeah.
Right. Well, they get that's basic arithmetic other ways, but yeah, I mean, it sort of goes without saying that you have to know basic arithmetic.
Mm.
Anything else? Any other big ideas that?
Well, there are lots of big ideas, but we're not going to talk about.
Right. Okay. Good idea. Good idea. So we'll stay focused to this. Yeah. So again, it's all unlike other questions like yesterday's, where it was very clear they wanted you to know the standard deviations related to spread. Here, there's so much going on in quadratic equations. It's not clear exactly which aspects, but basically understanding how to deal with quadratic equations, understanding what their roots are, and understanding what it means to have the implications of one distinct real root. And also, it doesn't help it doesn't hurt to just use the discriminant if you need it. If you use it, it's a nice tool to have. It's a little not the most coolest way of doing it, but it certainly will work. So I think we're done, right?
Yeah.
Yeah, we're done. Okay, great. Okay, everyone, I'm Joel. I have a PhD in mechanical engineering. My brother Seth has a PhD in math from MIT. He's been a teacher of computer science for many years at SUNY Albany. He's now retired. We're here to hopefully offer different approaches to doing math SAT questions. This is certainly an example of different approaches to do a math SAT question. It's good to look at the problems from different lenses. Even when you're studying, look at the questions and see if there's more than one way to do it, and try to think about all the alternatives, because sometimes a question will be sometimes one solution is better than another for a particular problem. And just practice as much as you can. Do the 4 digital SAT practice tests on the College Board website, and then whatever subjects you're a little weak on, go to Khan Academy. They offer about 30 or 40 questions on each topic, like literally each subtopic that you could study from. They partner with the SAT, so the questions are similar to SAT questions, and just improve and learn from your mistakes and just get better and better and better. Okay, I think that's it. Please leave comments. We take out all the comments very seriously. We appreciate all the comments. And if you have any SAT math questions you'd like us to do here, then please email them to us at satmathquestionoftheday@gmail.com.
Which is printed on the first page of this YouTube channel.
Yes, that's right. Yep. Okay, everyone, have a great day.